Hi, welcome back. This is section 5, and we're going to discuss challenges with machine learning. You'll come across many challenges in machine learning. There are a lot of poor quality and inconsistent data available. A significant portion of your job will be getting access to or generating enough good data that's representative of the problem you want to solve. A key issue to watch out for is under or overfitting the model. It's not all about the data, although it mostly is. Do you have data science experience? Is staffing a team of data scientists cost effective? Does management support using machine learning? What does the business landscape look like? Are the problems too complex to formulate into a machine learning problem? Can the resulting model be explained to the business? If it can't be explained, it might not get adopted. What's the cost of building, updating, and operating a machine learning solution? Finally, how does the technology map? Does the business unit have access to the data that's needed? Can the data be secured to meet any regulatory requirements? What tools and frameworks will be used? How will the solution integrate with other systems? These are important questions. To be successful, you'll need to be able to answer and address them. Many machine learning problems can be solved today by using existing models and without substantial machine learning knowledge. We've already talked about the AWS managed services for machine learning. You can add sophisticated machine learning capabilities to your applications with only some basic developer skills for calling APIs. There are other pre-built models you can use or adapt. One example is YOLO, which means you only look once. YOLO is a popular computer vision model. In addition to these scenarios, you can use the AWS Marketplace if you'd prefer to buy models and services from independent software vendors instead of developing your own. Here are the key takeaways for this section. First, you'll face many machine learning challenges. The biggest ones that you can directly influence are related to data. You should consider managed services to solve machine learning problems within the domains they support, such as using Amazon Rekognition for computer vision problems. That's it for this section. We'll see you in the next video.
Welcome to the demonstration of Amazon SageMaker. Amazon SageMaker is a fully managed service you can use to build, train, and deploy machine learning models quickly. Let's start out by reviewing the major features of Amazon SageMaker in the AWS console. Machine learning models require large, high-quality, labeled data sets. You can use ground truth to build these data sets. Amazon SageMaker notebook instances are fully managed machine learning compute instances running the Jupyter Notebook app. In this course, you will be using Jupyter Notebooks to prepare and process data, write code to train models, deploy models to Amazon SageMaker hosting, and test and validate your models. Amazon SageMaker provides features to monitor and manage the training and validation of machine learning models. You will be using many of the training features in the hands-on portion of this course. Once you have trained a model, you can deploy it with the Amazon SageMaker inference pipeline. And finally, you can find many pre-built models that you can leverage for a wide variety of machine learning use cases in the AWS Marketplace. In this demonstration, we will create a new Jupyter Notebook instance and have a quick look at how to add text and code to the notebook. To create a notebook instance, I will choose Notebook Instances and then Create Notebook Instance. I need to enter a name in the notebook instance name field. and then select an instance type from the notebook instance type list. I can then either specify an IAM role or create a new role from the IAM role list. And then I will accept the default value of any S3 bucket and then choose Create Role. Then I can choose Create Notebook Instance. Once the notebook instance status changes to in service, I can choose it from the list and then choose Open Jupyter to open it. You can use Jupyter Notebooks to write text, run code, and create visualizations. Let's have a look at the basic text and code editing tools. First, we'll create a new notebook. As you can see, we have a wide variety of development environments to choose from. For this demonstration, we'll pick Conda Python 3 to create an instance of the Conda runtime environment that supports Python version 3. You can see the descriptions of the various editing tools by hovering over them. First, you can save and checkpoint your work. You can insert cells. You can copy and paste cells. You can move cells up and down within the notebook. You can run an individual cell in the notebook and stop the notebook by interrupting the kernel. You can also reset the kernel, or you can choose to run the entire notebook. One thing to be aware of is that you can toggle between the types of cells between code and Markdown. You'll use Markdown to enter basic text that you want to display in the notebook. Let's have a look at how to add text to a cell using Markdown. First, we want to make sure and select the type of cell as being a Markdown cell. And then we can enter some Markdown into the cell. And then we run that cell. And you'll notice that it has switched it from Markdown into plain text. You can enter code the same way. Just make sure that the cell type has been set to code, and then enter the Python code you want to run. I will now add some code to demonstrate that. As you can see, Jupyter has run the code and put the output into the cell below the code. You will be creating notebooks and writing code in the hands-on labs for this course. This concludes the introductory demonstration for Amazon SageMaker. You can get more information about SageMaker at aws.amazon.com/SageMaker. Thanks for watching.
It's now time to review the module. Here are the main takeaways for this module. First, we looked at defining machine learning and how it fits into the broader AI landscape. We also looked at the types of problem machine learning can help us solve, and how machine learning applies learning algorithms to develop models from large data sets. We then looked at the machine learning pipeline and the different stages for developing a machine learning application. Finally, we introduced some of the tools and services you can use before discussing some of the challenges with machine learning. In summary, in this module, you learned how to recognize how machine learning and deep learning are part of artificial intelligence, describe artificial intelligence and machine learning terminology, identify how machine learning can be used to solve a business problem, describe the machine learning process, list the tools available to data scientists, identify when to use machine learning instead of traditional software development methods. Thanks for watching. We'll see you in the next video. Welcome back to AWS Academy Machine Learning. This is Module 3, and we're going to work through the entire machine learning pipeline by using Amazon SageMaker. This module will discuss a typical process for handling a machine learning problem. The machine learning pipeline can be applied to many machine learning problems. The focus is on supervised learning, but the process you learn in this module can be adapted to other types of machine learning as well. This is a large module, and we'll be covering a lot of material. At the end of this module, you'll be able to formulate a problem from a business request, obtain and secure data for machine learning, build a Jupyter notebook by using Amazon SageMaker, outline the process for evaluating data, explain why data needs to be pre-processed, use open source tools to examine and pre-process data, use Amazon SageMaker to train and host a machine learning model, use cross-validation to test the performance of a machine learning model, use a hosted model for inference, and finally, create an Amazon SageMaker hyperparameter tuning job to optimize a model's effectiveness. We're ready to get started? See you in the next video. Hi, and welcome back to Module 3. This is Section 1, and we're going to take a look at some of the data sets we'll use in this module. We'll also look at guidance for how to formulate a business problem. Before we get started, Here's a reminder of the machine learning pipeline we looked at in the previous module, and how that maps to the sections in this module. This section, Section 1, will cover how to formulate a problem. It will also cover the data sets we'll use throughout this module. Section 2 will discuss how to obtain and secure data for your machine learning activities. In Section 3, we'll show you tools and techniques for gaining an understanding of your data. Then, in Section 4, we'll look at pre-processing your data so it's ready to train a model. Section 5 will cover selecting and training an appropriate machine learning model. Section 6 will show you how to deploy a model so you can make a prediction. Section 7 will examine the process of evaluating the performance of a machine learning model. And finally, in Section 8, we'll look at tuning the model. The machine learning pipeline is an iterative process. When you work on a real-world problem, you might find yourself iterating many times before you arrive at a solution that meets your business's needs. In this first section, we'll examine how to think about turning a business requirement into a machine learning problem. The first step in this phase is to simply define the problem you want to solve and the goal you want to reach. Understanding the business goal is key because you'll use it to measure the performance of your solution. It's not unusual to solidify the business problem before you can begin targeting a solution. There are a lot of other questions you could ask to develop a good understanding of the problem. With more information about the problem, you can begin framing an approach. First, can the problem even be solved by machine learning? Or would a traditional approach make more sense? Is this a supervised or unsupervised machine learning problem? Do you have labeled data to train a supervised model? There are many questions you could ask yourself and the business. Ultimately, you should try to validate the use of machine learning, and you should make sure you have access to the right people and data. You should also try to come up with the simplest solution to the problem. Here's an example. You want to identify fraudulent credit card transactions so you can stop the transaction before it processes. That's your problem. Now, what's the business goal or outcome driving this problem statement? In this case, say that the intended outcome is a reduction in the number of customers who end their membership to the credit card as a result of a fraudulent transaction. From a business perspective, how do you define success given this problem and the desired outcome? This is the stage where you need to move from qualitative statements to quantitative statements that can be easily measured. Continuing with the example, a metric you could use to define success for this problem might be a 10% reduction in the number of customers who file claims for fraudulent transactions within a 6-month period. So now you've defined the business side of your problem. It's time to start thinking about this in terms of your machine learning model itself. What's the actual output you want to see from your model? You want to be specific here. It should be a statement that reflects what an ML model could actually output. An example might be, the model will output whether or not a credit card transaction is fraudulent or not fraudulent. Now that you know what you want your ML model to actually achieve, you can use this information to determine the type of ML you're working with. If you have historical data where customers filed reports for fraud transactions, you can use this data for your machine learning purpose. This historical data falls under the supervised learning approach, where the labels are already defined. Recall from earlier in this course that supervised ML types are categorized into 2 groups, classification and regression. In the credit card example, the desired output of categorizing a transaction is fraud or not fraud. So you can see that you're dealing with a binary classification problem. Throughout this module, you'll see several data sets being used. You can access these data sets and many more from the UC Irvine Machine Learning Repository. The first data set contains numerical information about the composition of wine, along with the quality of the wine. The question you might want to ask on this data set is, based on the composition of the wine, could we predict the quality and therefore the price? In addition to that question, we'll also use this data set to view statistics, deal with outliers, and scale numerical data. The second data set is a car evaluation database. This data set is heavily text-based. This enables you to explore the encoding categorical data, which converts the text values into numbers that can be processed by machine learning. The third data set is a biomedical data set, which you'll also use in the labs. The question to answer for this data set is, based on the biomechanical features, can you predict if a patient has an abnormality? This data set will take you through the entire end-to-end process. You'll end with a trained model that's been tuned and that you can use to make a prediction. In this section, we looked at how business problems need to be converted into an ML problem. We also looked at some of the key questions to ask, which are, what is defining success? Can you measure the outcome or impact if your solution is implemented? Most business problems fall into one of two categories. The first category is classification, which can be binary or multi-class. Ask yourself, does the target belong to a class? And the second category is regression. For this, ask yourself, can you predict a numerical value? That's it for section 1. We'll see you in the next video.